Okay, experiment number 5 is determination of the endpoint of a titration and solubility product using conductiometry. So here we will discuss only first experiment to determine the endpoint of a reaction by using conductiometric experiments. So we will use a conductivity meter. Here it has a digital screen and there is a electrode, conductivity meter cell. Here the edge of the conductivity meter cell containing two metal plates. So we will dip this edge in a particular solution. We have to fully immerse the edge of this conductivity meter cell in a particular solution. We are going to measure the conductance. So we have to immerse this cell, the edge of this conductivity meter cell, we have to fully immersed. If the two plates are immersed halfly, the readings will be provide an error. So we have to fully immerse the two plates in this solution. That's the first thing we have to remember. It's the electrode. Two metal plates are there. We will conduct the conductance among these two metals. So we have to fully immerse them in a particular solution. So that's the first thing you have to remember. So here we have provided 10 ml of 0.1 m HCl solution. We have provided 10 ml, 10.00 ml of HCl solution. Very small amount, 10 ml mean. Okay, and we have to titrate it with sodium hydroxide. We will put, we will keep this 10 ml HCl in a conical flask or titration flask. Here our burette will fill with NaOH, sodium hydroxide. What is the concentration? Concentration will be 0.1. Here HCl also 0.1. So we know what will be the endpoint. We know about according to the stoichiometry, it is 1:1 HCl and sodium hydroxide. Here NaCl and H2O will be the products. Here it is a strong acid, here it is a strong base. So endpoint will be near pH 7. However, according to conductiometry, we have to know these things initially. We have to know conductance or mobility of H plus ions. Mobility of H plus ions is very higher than OH minus. Very higher than OH minus. However, OH minus mobility is higher than other ions. This thing you have to keep in mind. Mobility means conductance also higher in H plus than OH minus. So OH minus's conductance will be higher than other ions, likewise sodium and chloride likewise. Then OH minus mobility will higher than those other ions in the solution. So that thing you have to keep in your mind very carefully. Okay. Now what we are going to do, here the provided HCl volume is 10 ml. If we add this 10 ml, so we are going to do this experiment in a beaker. We have provided beaker, 200 ml beaker. So we will place this 10 ml HCl in this beaker. However, now we have to immerse our conductivity meter cell in this solution. So we will insert, but there is a matter. What is that? The two metal plates are not fully immersed. because the volume of this beaker is not sufficient to immerse the metal plates. If I enlarge this structure, this is the conductivity meter cell edge, two metal plates. We are measuring conductance among these two metal plates. However, the HCl volume is, this is your beaker, this is HCl solution. So these two metal plates are not fully immersed. සම්පූර්ණයෙන්ම ගිලිලා නැහැ යාලා. මේක සම්පූර්ණයෙන්ම ගිලිලා තියෙන්න ඕන conductance මනින්න නම්. So there is an error. To reduce that error, we will add sufficient amount of water, distilled water. Actually, the correct procedure is deionized water. Deionized means there are no any ions. There is no any ion in this water. Deionized means because of that we can neglect the conductance of water because we are using deionized water. There is no any conductance things. However, in our lab we using distilled water. We assume the conductance of distilled water is 0. However, we add around 100 ml of water into this solution. We add around 100 ml of water to this beaker to adjust the volume, solvent level. However, the containing HCl is same. 10 ml is same. So mole N of NHCl or mole of HCl is number of moles of HCl is same. It doesn't matter if we add water, number of mole of HCl is same. We don't add HCl or we don't remove HCl from this solution. N number is same. So conductance also will be same after adding water. Doesn't matter. Okay. Now we add water. After adding water, the volume will be higher. So two metal plates of the conductivity meter cell will be fully immersed. Not only that, now we add conductivity meter cell, water and HCl, and we have to know the temperature also, this solution. We will add a thermometer. Okay. However, we have to stir this solution very well during this titration. Now we are adding sodium hydroxide from the burette, NaOH from the burette. Okay. So when we add 1 ml portions of, because initially we have to read the conductance of HCl. We will plot a graph. Here added NaOH volume in milliliters. Here conductance. So initially we know the mobility of H plus is very higher. Initially the solution contain only H plus. Initially H plus විතරයි මේකේ තියෙන්නේ. ඉතින් එයාගේ conductance එක වැඩි වෙන්න ඕන. So its conductance will be here initially very high because this contain only H plus. Okay. And we know HCl. Cl, there are Cl also. H plus and Cl minus. We know the conductance of other ions are very low compared to these two major ions, OH and H plus. So here Cl minus also here, but its conductance is very low. However, with compared to H plus, its conductance like this, very high. Okay. We add 1 ml of NaOH into this solution and we will stir very well. We have to mix very well to get a homogeneous solution, and reaction will happen and it is solution mixture will be uniform. So we will use magnetic stirrer. We will use a magnetic stirrer. This all set of the experiment, this beaker we will keep on a magnetic stirrer instrument. There is a knob and we can adjust the speed of magnetic tablet. We add magnetic tablet and we will switch on and we will adjust the speed of this rotation speed of this magnetic tablet. So when we are using this magnetic tablet, we have to take care about the conductivity meter cell. Edge of this containing a glass cover, it will be broken if the magnetic stirrer hit the glass cover. So we have to take care about that also. We are not using glass rod because that's a very old method. Using glass rod we can stir, however it is not uniform, we can't achieve a uniform distribution of our reactants, because it is depend on our there are so many human errors when we are using glass rod. So nowadays we are using magnetic stirrer. Okay, now we will titrate. We add 1 ml of sodium hydroxide and we will stir very well, and we will read the conductance value. What happen if we add sodium hydroxide? Some amount of, we add OH minus here, it will react with H plus and it will produce H2O. Now what will happen? OH minus is added but it is neutralized by H plus, so H2O is producing. What happened? The concentration of H plus is decreasing by adding OH minus, because H plus is neutralized with OH minus and produce H2O. Now what will happen? When we adding sodium hydroxide, H plus concentration will be low. That means mobility of H plus also low. It decreasing because concentration will be decreasing. So when we adding H plus, what happen? The conductance will be getting lower because number of H plus ions decreasing. So conductance will be decreasing. Initially, the gap between this decrement, we add 1 ml portion and we stir well and we get reading. And again we will add 1 ml and we will get the reading. Again we add 1 ml, likewise we add 1 ml portions. Initially the readings will be very close to each other. However, after some time, the gap between the readings will be somewhat higher. Gap will be somewhat higher. That means now we are reaching to the end point. At that time, we will add dropwise sodium hydroxide. We are not adding 1 ml. Now we are adding dropwise. At that time, we can see the gap between 2 points will be higher and higher. 1 point, what will happen? The graph will be goes opposite direction. Again it will be increasing. Again it will be increasing like this. Why is that? That means at some point all H plus ions are neutralized. After neutralizing, because we are adding OH minus, so H plus ions will be neutralized. After all H plus ion neutralized, now what will happen? We are adding sodium hydroxide, so that excess OH minus will remain in the solution because there are no any H plus ions to react. නේද? අපි දැන් මෙහාව ටික ටික ටයිට්‍රේට් කරගෙන යනකොට sodium hydroxide දෙකේ HCl නිතරම react කරන්න පටන් ගන්නවා. end H plus OH minus එක neutralize වෙනවා. එතකොට මොකද වෙන්නේ? H plus අඩු වෙනවා. H plus අඩු වෙනකොට අපි දන්නවනේ H plus වල mobility එක වැඩි, conductance වැඩි කියලා. H plus අඩු වෙනවා කියන්නේ conductance කරන්න තියෙන අයන ප්‍රමාණය අඩු වෙනවා. ඒ හින්දා මේක එන්න පල්ලෙහාට යනකොට අඩු වුණා. මේ conductance value එක. හැබැයි එක point එකකදී මොකද වෙන්නේ? එකපාරම වැඩි වෙන්න පටන් ගන්නවා conductance. ඒ මොකද වෙන්නේ? H plus ඔක්කොම react කරලා ඉවරයි. දැන් reaction mixture එකේ ඉන්නේ OH minus. අපි වැඩිපුර දානවා sodium hydroxide උඩින්. දැන් ඉන්නේ OH minus. Because of OH minus, again the graph will increase. However, the gradient, here the gradient is like this. However, when we adding excess sodium hydroxide, its gradient is ඒකේ අනුක්‍රමණය අඩුයි. Gradient is lower than the previous one. So this type of graph will obtain by this experiment. So this part is because of H plus and this part because of OH minus. When we interpolate this into x-axis, we can read the volume of NaOH at this point, that means end point. This method is very accurate than when we are using indicator, phenolphthalein, methyl orange, likewise indicators. Indicators mean those are weak acid or bases. They also consume some amount of titrant. So that is somewhat error containing method. However, in conductometry meter, when we are using conductiometric data for titration, that is more accurate than sophisticated titration methods which are using indicators. We can read the endpoint likewise. Here, if we consume this much volume, here V1 volume, so to get the other portion of this graph, we have to add another V1 volume. So total sodium hydroxide volume, NaOH total volume is equal to V1. Okay. To achieve the endpoint, we have to add V1 portion. To complete this graph, we have to add another V1 volume. So 2 V1 volume will be consumed throughout this graph. So this is the summary of this experiment, conductivity metric titration. However, there are some important things you have to remember. These things. We are using 10 ml pipettes, 10 ml pipette to pipette out our HCl solution. We have provided 0.1 m HCl. We are using 10.00 ml pipette or graduated pipette to measure, because when we are dealing with 2 decimal points, we are using graduated pipette or 10 ml pipette. Okay, we are using burette, so we are using beaker to do this experiment, because if we use this type of conical flask, what will happen? Its neck is very narrow. Neck of the conical flask is very narrow, so we can't insert this conductivity meter cell, and we can't titrate, and we have to stir very well. We have to check the temperature also. So we have to input so many things into this vessel. So in conical flask, its neck is very narrow, so we can't use that. Instead of that, we are using beaker. You have to remember that. 200 ml beaker. Okay. Every glassware should clean very well. First distill water. Second, we have to rinse with distilled water. First one is tap water. Initially we have to wash with tap water. Next, we are rinsing with distilled water. After that, the pipettes and burettes we have to wash with relevant solution. Relevant solution we are going to measure from that device. Okay. We add 100 ml of water. We add 100 ml of water into this beaker to adjust the volume. We just mentioned 100 ml, not decimal points. So we are using measuring cylinder to measure that water. Okay. We have to stir the solution throughout the experiment to achieve a homogeneous mixture. And we are using magnetic stirrer because it is very sophisticated, and it is more effective and convenient than old method. Likewise, like we are using normal stirrer. It's metal. It contains a metal ring edge. So those are very sophisticated. And glass rod we can use. Those are very old methods. But compared to them, magnetic stirrer is very effective and convenient. And we have to care about when we are using magnetic stirrer, it can damage the conductivity meter cell. So we have to careful about that magnetic stirrer. When we are switch on it, we have to make sure the edge of the conductivity meter cell is not close to the magnetic stirrer, magnetic tablet. Okay. We are using 50 ml burette to add sodium hydroxide to titration. We have to use white tile also. Actually, we are not using white tile, okay, because this is not a colorimetric method. We will consume around 2 V1 to get the first graph, we have to use V1 volume. It will be 10 ml. After getting endpoint, we have to complete the graph. We have to add another 10 ml. Total volume will be 20 ml. Okay. That's the end of experiment number 5, which is conductivity meter experiment. Now we will move on to 6th experiment, pH meter.